Now, in the previous videos, we talked about how you would name an alkane chain by first looking for the longest primary chain. But what if there's multiple ways to get a longest primary chain? So the structure I've got up on the right, I've highlighted a blue line and a red line. Now, both of these are 5 carbons, so we would name both of them pentanes. But what should we consider the 5-carbon chain because they both contain 5 carbons? Well, here we're going to take a look at the formula as if we assumed we had the red line, carbons, versus the blue line. So let's take a look at the red line first. If we do the red, we have a methyl group in the 3rd carbon position, so this would be 3-methyl. And here we have an isopropyl on the 3, so 3-isopropyl. So 3-isopropyl, 3-methyl if we follow the red chain. How about the blue chain? Well, if we do the blue chain, we have a 2,3-dimethyl and a 3-methyl. So this would be 3-ethyl, 2,3-dimethyl pentane. Now your instinct here may be to sit back and say, well, we want the one with less substituents on it because it's easier to write out. Actually, it's the opposite of that. If we have 2 ways to draw the longest carbon chain, we actually want to pick out the one that has the most number of substituents or branches on the chain. The reason being is that if you compare these two, we have an ethyl versus an isopropyl. An isopropyl is a more complicated group, and what we want to do is create a whole bunch of groups on the parent chain because that will make them easier to name. So let's say we had 3 over here. In this case, you would have 2, sorry for crunching up here, 3-ethyl, 2,2,3-trimethyl pentane. You still have your propyl group, but you'd actually have a sec-butyl at this point. I'm sorry, tert-butyl. So the reason for wanting to stick with this as many substituents on the longest chain reasoning is that we want the substituents to be as simple to describe as possible. When we get to something like this where we've got 3 carbons connected to 1 carbon connected to our chain, we end up having to kind of do these non-IUPAC names to name what's going on here. Whereas if we do a chain that has as many substituents as possible, more than likely we're going to end up with things like ethyl, methyl, simple things that we're used to working with. So this is what you do if you have a branched alkane and you've got more than one way to write the longest chain.